Okay, so here, today we want to explain the project of Matpower and to operate the baseload case and the PSO case. But before that, if you open the base case file and after that run it this file, it will be get the error because the load case it is not defined or unorganized function or variables. So before start to operate the base case and the PSO case in the Matpower, it should be to install the Matpower as you see here in that file, and after that open it, and as you see there is a file installed Matpower. Open it, and after that run this install Matpower before start. After we run it, it display the command. Please enter your selection 1 2 3. The default is 1, but the question is do not modify the MATLAB path. Do modify the MATLAB path, but only temporarily, or do modify the MATLAB path and save updated. We select the third one, 3, and after that press enter, and after that, as you see here, your MATLAB path will be updated using the following command, and then any key to continue, press enter. And would you like after that show appear or show appear the another question appear here? Would you like to run the Matpower test now? Press yes to test that. As you see here, it is all thing or command or line, it should be okay. As you see here, okay, and wait to finish this test Matpower. Wait that okay, all that okay. So, and after that, after finished, it will get another question. It should be in case the load case okay, Jacobian okay, MB table okay, all of them okay. It should be get it in your case. Okay, we will wait some minutes to that, and okay, all of them okay, and then we are still waiting that run power flows, waiting it's take several times to finished, and after finished we will back to you. Okay, okay, as you see here, after we finished the testing, now it is all test successfully passed, and to skip some thing else. This is now it is the Matpower, it is ready. Now back to the base case, and as you see, run it, the base case. Now it will be get the result. as you see here. So as you mentioned in the last video, the first video, it should be installed the Matpower before, and after that open it and install the Matpower as the procedure in video 1, and after finish testing, now we can run the base case, also the PSO case. But before we finish this video, we will explain the base case. The base case is simple. In the Matpower, it have the command like this: load case 33 bus network, and then after we load the case in the network, it is install the all specification of the case 33 bus network. And then this the database, it put it in the command run optimal power flow of that network, and this is make the optimal power flow for the system IEEE 33 bus. Then the run optimal power flow printed the result as you see here. I printed how many buses, generator, committed generator, loads, how many loads, how many fixed load and dispatchable loads, shunt, how many the branches موجود, this is mean the lines, and the transformers, and all the how much the total generation, that one line capacity generation actually, and the load, how many the load, fixed load and the dispatchable load, as you see here, the real power and reactive power. And also we have another table about what is the voltage magnitude, the minimum and the maximum, and the voltage and the minimum maximum power loss, how many the maximum power loss in the line as you see here. And this is for other purposes, and the lambda of the P real power and reactive power. And also we have also table tell about the bus data, what is the magnitude of voltage of each buses, the power generation of each buses, the load for each buses, the lambda of each buses. And also we have also the table in the result or branch data, as you see here, branches data for what is each branch, the number of branch, the branch is from bus to bus, as example from bus 1 to 2 to bus 2, this is the branch, the line, and how many the power injected in this real power and reactive power, and the injected to the bus 2, as you see here. And after that, what is the losses in each line, real losses and reactive power losses for each branch, and also the total. It is in the megawatt, sorry. It is the megawatt and megavar, right, this. And the last one, it is the constraint, as you see here. We have the minimum value 1, absolute, the bus 1. It is have a constraint, as you see here. This is the output of the run optimal power flow in the base case. In this case, do not do anything, only get the case from the database of the Matpower, and after that make it the optimal power flow for that network and get it the result. In the second video we will make some changes and make the PSO to get the new result and better result for that. And in the next video we will explain the PSO case and how it works. Thank you very much. We hope it is understand. If you have any question, we're ready to answer you and help you to understand all the things. Thank you very much. Okay, sir, this is the third video for explanation the code that we use the PSO case for Matpower, as we mentioned in the two previous code. It should be the first thing, it is to install the Matpower, and after that the code it will be run. Today's after we finished from explain the base case. Today we will go to through the PSO particle swarm theorem case to explain how to work, and maybe in the next video we will explain the result. But before that result, now start to explain the code. As you see here, the first file, it is the profile. In the profile we have a profile for 24 hours for IEEE 33 buses system in per units. We have three type of profile. The first thing, it is the load profile. The second, it is the PV photovoltaic profile during the 24 hours, and the last column, it is for the profile for battery storage. As you see here in the profile of the battery storage, we have positive value and negative values, but the positive value, it is mean that as charging the battery, and the negative value, it is mean that discharging the battery. This is the first file, and the second file, it is the PSO case. It is the main case program. From here we can run the program. As you see here, clear all the variables and CLC the command window, and after that go to the PSO function that will be explained later, and after we get the best solution from the optimization, apply this best solution on the result function to get the result. As you see here, to get the size of PV and the size of battery storage and the size of the location for the PV and battery storage, and then also the power flow result, the power losses and voltage deviations. This is the main program. If you go to the optimization PSO file, now the PSO, it is implementation of the particle swarm optimization MATLAB. The first thing, it is to problem definition. As you see here, the number of variables, decision variables, the number of decision variable threes, it is the size of PV, the size of the battery storage, and the location of the PV and battery storage. As you see here, we have lower band parameter, the range of optimization for the three variables, the lower and the upper. And as you see here, the PV size from 0 to 6 kilowatt, and the same thing for battery, and the location from 2 to the 33 bus. And after optimize that, after problem definition, now PSO parameters as maximum iteration, the population size, the inertial PSO parameters, the inertia weight, damping ratio, the personal learning coefficient, the global learning, and the velocity limits. It should be between the minus value of the maximum velocity and the 0.1, between the difference between the maximum and minimum value of the variables. And after that, initialization started. As you see here, started with empty particle position and particle cost, velocity, best cost, and best position and best cost particle. And then we also define the global best. In the first step, as you see here, it is the initialization process before we go to the main loop. As you see here, initialize the position, the particle for each position. Each particle is contained, as we defined before, it is contain the size of PV, the size of PS battery storage, and the location of the battery and photovoltaic. It is in the initialize the position process. It is the first thing, in the initialization process we define the particle randomly, and after that we defined or initialize and assume the velocity of each particle, it is 0, and then we evaluate the cost function that we will explain later. And after we calculated the cost function from each particles. We get the particle cost stored in the particle cost, and after that updated personal best, because we don't have any other historical cost for each particle. Now we consider the cost that we get it from the initialization process as a best position and best cost, and then we will update the global best. The global best, it is mean that the compare between all the particles that we existed here, and get it the best one, the particle that gets the fitness function, it is lowest compared with other particles, and it is repeated this process for all the number of particles, and then also we initialize the best cost, it is 0 for the maximum iteration. After we finish the initialization process, now we go to the next step for the PSO main loop. We started with the iteration from 1 to the maximum iteration that we defined before, and after that, depending on the initialization process, now we will update the velocity. As you see here, the velocity of each particle, it is dependent on the initial velocity, and also the particle, the best position of the particle, and the current particle position, multiplied by the random and some factors, and also some with which is the global best, and the difference between the global best position and the current position of the particles. And after that, we calculated the velocity for each particles, and after we calculated the velocity, we applied the velocity limits, and then we updated the current position. The current position is dependent on the new position, sorry, it is dependent on the current position, sum of the velocity of each particles. So after we updated the position, we applied the position limit. We see if the new particle position is in the range of the minimum and maximum values that we considered or not, and after that we applied this limit on the particle and get the new position. And after we get the new particle position, now we go to the cost function to calculate it, or evaluation the particle cost, the new particle cost. The new particle cost of the new position, now we compared with the best that we stored from the initialization. If the cost of particles now it is less than the best cost that we get it in the initialization, now updated the particle position, the best particle position, and the best cost particles, as you see here. If not, we go also to update the global. We compared with the global best. If the new particle get the lowest value compared with the global best, now we updated the global best value and repeated the process for the first for the number of population or particles, and then we printed the best value that we get it from the first iteration on the screen, as you show here. So after that, we repeated this process for the number of iteration, and in the second iteration, now we have initial velocity from the first iteration, and we have the best and the current one, the new current one, and the global one, the new global position if you updated, and the particle position, and then we calculated the velocity, the new velocity, new particle position, depending on the new current position that we get it from the first iteration, and the new velocities that we calculated before, and then we get the another new position particles, and then applied the position limits and evaluation the cost function, and updated the personal best, and updated the global best, and repeated this process, and then also printed the best value on the command window, and repeated this for the maximum iteration. After we get the best position, the best solution from the global best, as we mentioned, the best solution contain the installed capacity of PV, installed capacity of battery storage, and the location of that battery and the PV, and then we printed the best function our best cost, how the fitness function behave with the iteration in the graph. This is the process. Now after we finish the PSO, as you mentioned before, we go to the result function, get it the best solution, and put it in the result function to get it the result. The result function, it is for the same thing of the cost function that we will explain in the next video. We hope it is clear for you. If you have any question, we are ready to answer you, and we will help you as much as possible. Thank you for your listening, and see you next video. Okay, this is the last video to explain the code that we get it. The cost function. The cost function, it is the function which is what is the how to calculate, or this is in the calculated the fitness value. The fitness value, it is dependent on the load flow, as you see here. And the first thing, this is parameters that get it from the PSO optimization, and then the warning off to prevent any warning during the load flow process. And after that, we load the profile. This is the profile, and then we make the load case 33 pass. And after that, now we calculated, we get it the generation, as you see here, and get it from the network load. This is the load case. That means the network, we get it the network case 33 pass. And after we get it the load, the case 33, now we put the generation in the generation 2 and the net 1 generation cost, and put it the PL and voltage division, it equals 0, and then applied for 24 hours. And as you see here, now we put it the network specification of IEEE 33 bus in the network, and then we applied, as you see here, applied the PV generation dependent on the size of PV, and also the profile of the PV, as you see here, and get it the PV, the generation from the PV for each hours. And after that, the same thing for the batteries. And then the net generation, because it is in the same pass, the net generation, it is get it here. And after that, after we get it the net generation, now we apply this net generation to be located, as you see here in the generation. We located that. And after that, after we located the net generation, now we make the run the optimal power flow after we located the net generation from the PV, the PS. And after we run this load flow, now we calculated the power loss and the voltage deviation for each hours, as you see here. Then repeated this process for 24 hours. And after that, we get or calculated the power, the voltage, the fitness values by summing between the power loss and voltage division divided the 33. This is the number of buses to calculate the average voltage deviation on each buses. So after that, this is values that we get it in the PSO and optimize this value to be lowest than possible, and get it the best solution that make this fitness value it is lowest as much as possible. So this is the idea of cost function, and the result the same thing. But put it some plot for the result. I will explain later soon. But as you see here, the only thing it is to calculate the generation from the PV each hour, and the load or the generation from the battery storage in each hour. And after that, we calculated the net generation and located in the generation information. and then we make the optimal power flow to calculate the power loss and voltage division. In the result function, as you see, the same of the fitness function, but in the last code we plotted some thing about the profiles, the profile of daily system load, grid, PV, battery storage, as you see here. And this is and after we get it the power loss and voltage deviation for the best solution and printed in the command window, as you see here. We hope it is clear for you. If you have any question or misunderstand of the code, you can ask anything. We hope it is clear, and thank you for your listening, and see you next time.